Hello boys and girls, this is Mrs. Wingervasu, and today we're going to be covering Chapter 5, Lesson 5.2 on proportions. Reference pages to this can be found in your textbooks, pages 172 and 173. Don't forget, as a reminder, you need to take down all the notes in today's video for full credit. Okay, let's go ahead and get started with some key ideas. I'm going to talk about two in this page. So we're going to first talk about what a proportion is. A proportion basically is it's an equation. And remember, when we have an equation, you need to have an equal sign, stating that two ratios. So it's an equation with an equal sign that has how many? Two ratios. So I'm going to use this example here. 2/3. That is one ratio. An equation has to have an equal sign. That's an equal sign. And a proportion has to have two of them. So here's my second ratio. So a proportion is an equation. Here's my equal sign. That has two ratios. Here's two of my ratios. So this is called a proportion. Two ratios with an equal sign. Now, when you have two of them, two quantities that form a proportion, they could be called what is called a proportional. What does it mean when they are proportional? That means they are the same. Now, if you look at this example, you may not think it's the same, but it could be the same. So how can we figure out if these two fractions, these two ratios are the same or not? And this is what we're going to talk about in today's video. So let's go ahead and do our first example. In our first example we have here, I'm going to go ahead and just show you this much. It says here, tell whether 6/4 and 8/12 forms a proportion. In other words, are they the same? A proportion means if they are the same. And the other word we can use for it is proportional. Are they proportional? So what I'm going to do is I'm going to set this up as a proportion problem by writing 6/4 equals 8/12. Now, to find out if they're the same, what we can do is reduce them. We learned how to reduce this in previous chapters and previous lessons. So to reduce this, I can think about a number I can reduce it by for this side, which is 2. So 6 divided by 2 is going to be 3. 4 divided by 2 is going to be 2. So this side is 3/2 instead of 6/4 now. Equal, what can I divide this side by? Well, 8 and 12 can go into 4. So 8 divided by 4 is going to be 2. 12 divided by 4 is going to be 3. Okay, now I'm going to box this so you can see we have two ratios, so that's a proportion. But we want to know, is it a proportional problem? Is it the same? It doesn't look the same here. Actually, it doesn't look the same here. Even when we reduce it, it still doesn't look the same. So in other words, we would say this is a no. It is not a proportional problem. It's not the same. So let's go ahead and take a look at some more examples. The next example I have is 4/8 and 3/9. Again, to find out if they are the same or proportional, we're going to reduce. And to do that, don't forget you also need to put an equal sign in between. If you don't put an equal sign in the between, it's not a proportion anymore. It's just two ratios. So you have to have that equal sign to make it a proportion. So now, let's go ahead and see if we can simplify this one. It looks like we can just simplify it by 4. So this side's going to be 1/8 divided by 4 is 2. The other side, I can simplify it by 3, which is going to be 1/3. Now again, they don't look the same here in black, but in green, they still don't look the same. So, and don't forget the equal sign, I'm going to have to say the second one that I have here is also a no. It is not the same. In other words, it's not proportional. Proportional means it's not the same. Okay. Now, I'm sorry, proportional means it's the same, but if it's not the same, you say not proportional. Now, my next example I have here, let's see if they are the same. We have 2/3. Since you can't do anything or reduce 2/3, we'll leave it alone. And don't forget, you need to make sure you set the equal sign in between them to make it a proportion. So let me go ahead and go back to this and box this so you can see. Okay, and I'm going to box the second one so you can see. So since I can't reduce this first one, I'm going to leave it alone. And let's see if I can reduce the second one. 4/6 can be reduced by 2. So I'm going to say 4 divided by 2 is 2. 6 divided by 2 is 3. I finally found my first proportional proportion. They are the same. They didn't look the same here, but when I solved it and reduced it, they are the same. So this answer would be yes. Our last one I have here is going to be 5/9 and 6/18. So for this one, I'm going to look to see if I can reduce the first one. And it looks like I can't, so I'm going to go ahead and leave it alone. And don't forget, we have to have the equal sign in between them to make it a proportion. If you don't have the equal sign, it's not a proportion. 6 over 18, I can reduce it by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. So let's take a look. They are not the same here, and they're not the same here. So therefore, this third example is not proportional, or not a proportion. So no, no, yes, yes. Again, a proportion is when you have two ratios, set it up with an equal sign in the middle. But if you want to know if they are proportional, they have to have the same values. This one doesn't, and this is the only one that does. Okay? All right. So our next one I have here is going to be the same example, but this time it's given not in a sentence form, it's given in a table form. So if you have a table and you want to know if x and y are the same proportion or if they're proportional, choose two values. And when you choose two, you have to choose one from the x and one from the y. Remember, you don't graph x, x, and you don't graph y, y. So you have to choose one from the x and choose one from the y. I'm going to look at my graph or my table, and I notice that there are whole numbers and fractions. I don't know about you boys and girls, but I like to deal with whole numbers, so I'm going to choose this one, 1 and 6, because it's a whole number, and 2 and 12. If you want to work with fractions, you can, but I always highly recommend using the ones with whole numbers. If you want to use fractions, you can though, and I can show you how to set it up in this next step. Okay, so to write a proportion, you need to have two ratios. So I'm going to take this first one and put 1 over 6 as my first ratio. And since I started with x first, the second one I'm going to also start with x. So I'm going to put 2 over 12. Remember, a proportion has to have an equal sign. Now, to figure out if they are proportional, I'm going to go ahead and reduce it like we did in our first example. Can I reduce this one? Nope, so I'm going to keep it. Can I reduce the second ratio? Yes, so I'm going to reduce it, and that's going to be 2. What's 2 divided by 2? That's 1. What's 12 divided by 2? That's 6. And put the equal sign in the middle. Are they the same? Yes, they are. Since they are the same, we will say yes. Now, I just realized something in my last example. Let me go back. If they are not the same, I forgot to mention that what you can do is you can put a slash in between that says no. So put a slash in between the equal sign that represents no. This one we won't because it's a yes, and this last one we will because it's a no. So will we put a slash in between this one? No, because it's the same, so it's a yes. Okay, so I was telling you, you could use fractions if you want. So if you wanted to do it as a fraction form, it would look like this. 1/2 over 3 equals, let's choose this one, 3/2 over 9. It just means that you have to solve it differently. You can't divide a fraction, so you have to multiply by the reciprocal. Same thing with this one. So therefore, I like to work with whole numbers instead. Okay? All right, so what we've been doing is we've been taking our ratios and reducing them to see if they are the same on each side. Now, I'm going to show you in the next example 3, there's another way you can figure out if they are proportional or not. You don't have to just reduce, and I'm going to show you how you can do that in our next example. But before we do that, go ahead and take out a piece of paper and start your homework for today, the on your own, problems 1 through 5, just like the examples we just did. If I'm going too fast, if you need more time for this, please pause it and continue the video on to copy down the next part. Okay? All right, example, before we do example 3, let's do the next key idea, and this is the last one. I'm going to talk about cross products. What are cross products? Cross products are when you have two ratios. Here's one, and it's set up as a proportion. A proportion has to have an equal sign. And what you do is you just crisscross from top to bottom here, A to D as C to B. So I have here an example below, 2/3 and 4/6. All you need to do is cross 2 to 6 and 4 to 3. And when you cross products with it, products means to multiply, you're going to do 2 times 6. What's 2 times 6? 2 times 6 is 12. And then we're going to do 2, 3, and 4. 3 times 4 is also 12. So now, if you notice there's an equal sign here, you need to put the equal sign there also. Look at it. Is 12 the same as 12? Yes. If it's a yes, then this is called a proportional proportion. So this is another way you can figure out if a proportion is proportional, the same, in other words, the same or not. Not just by reducing, but by doing cross products. Okay? Let's go ahead and do our example then. So it says here, you swim your first 4 laps in 2.4 minutes. We're going to go ahead and set this up as a ratio. So I'm going to go ahead and set this up by writing, I know it says laps first, but it's going to be a lot easier if you put minutes on top. So I'm going to put 2.4 minutes on top over 4 laps. And I know I always say write what it says, but in this case, it's going to be preferred that you put minutes on top. So if you're talking about time, time usually goes on top as well, just like money. Okay, so if I have minutes here on this side, when I write my proportion, remember, ladies and gentlemen, when you write a proportion, you need to make sure that what you have on this side, I'm going to circle it or highlight it for you, what you have on this side is the same on the other side. So if I have minutes over here on the left, I'm going to have to put minutes over here on the left on the top as well. If I have laps here on the left at the bottom, I have to put it at the bottom as well. A proportion means they have to be the same. Okay, so we're putting it in the same spot. Now, it says you complete 16 laps. Where does 16 laps go? Top or bottom? Bottoms, because we're talking about laps. And then in 12 minutes, where does 12 minutes go? On the top. Now, you can do one of two things like I showed you in today's lesson. You can reduce each side, or you can do what I just showed you, cross product. I personally like the cross product most of the time, but sometimes reducing is the easiest. So it depends on the problem. In this case, I'm going to do cross product. So I'm going to do 2.4 times 16. Oops, 2.4 times 16. And then I'm going to also do on the other side 4 times 12. 4 times 12. Oops, that's a 12, I promise. Okay, so when I do 4 times 12, I know 4 times 12 is 48. And then when I do 2.4 times 16, that's actually not going to give me 40, but just going to give me 38.4. Now, if I compare these two values, they're not the same. So what can I say about these two ratios and this proportion? They are not the same. So in other words, they are not proportional. So I'm going to set an equal sign in the middle for both of this. We're going to say it's not proportion. So the answer is no. Is the number of laps proportional to your time? No. Okay, so go ahead and do number 6 on your own, the last problem for tonight's homework, and do this on the same paper, including the exit ticket here. So I'm going to go back, sorry. If I went too fast on this page, this slide, problem number 6, go ahead and pause it so you have more time. But please do this problem and also this problem for homework tonight. Okay, if you have any questions on proportions, please bring those questions to class tomorrow. I'll be more than happy to answer them. Have a great day. Bye.